You are listening to Climate Now. I'm Catherine Gorman.
And I'm James Lawler, and in this episode we'll be diving into the science behind reforestation strategies that are currently part of the global effort to pull anthropogenic or human-caused CO2 out of the atmosphere.
Today, our guest is Susan Cook-Patton. She's a senior forest restoration scientist on the Natural Climate Solutions Science team at the Nature Conservancy. Susan, thank you so much for taking the time to join us today.
Thank you for having me.
So we ask all of our guests the same question first. Tell us about how you got where you are. What's been your journey?
Gosh, my career journey has been a little convoluted, so I'll try to give you the brief version, or maybe I'll just tell you what motivates me to do the work that I do, which is that climate change is the biggest challenge facing our generation, potentially the history of our globe. And I thought very long and hard about whether or not to have children, but in the end, I decided to. So now I have two anchors towards the future, as well as an entire globe worth of children that will inherit our Earth. And I feel very lucky that I get to work in a field where I'm helping to find solutions to this big problem.
Excellent. So you were attracted by the low stakes. This was a field that was going to be easy for you
exactly.
to get into. Got it.
Things that let me sleep easy at night.
Awesome. So tell me about your academic work. Let's dive in there.
I didn't know what I wanted to be when I grew up. I got undergraduate degree in biology, psychology, and English, and didn't actually realize that people were still studying organisms and how the world worked, which is what I love. I love to understand how complicated nature is and how we can use it to help tackle the climate crisis ahead of us. And I eventually got a PhD in plant insect community ecology, which was really fun to look at all kinds of bugs on plants. But as I said, I was really driven to help tackle climate change. And so I had sort of multiple hop, skip, jumps where I started asking similar questions about how diverse systems are more stable and resilient to change. But these were in sort of grassland ecosystems. And then I, as a postdoc at the Smithsonian, was able to ask similar questions, but with forest, because trees are much more relevant for locking up carbon than grasslands, though grasslands definitely have a role to play. And then from there, I got a job at the US Forest Service, where I started to learn about all the other things that are important, like policies for helping to tackle climate change. And from there, I was lucky enough to get a job at the Nature Conservancy, where I've been for 4.5 years.
So starting with some of the basics, what are the dynamics by which forests absorb carbon from the atmosphere, and how well are those dynamics understood?
Yes, well, we're always trying to find these technologies for sucking carbon dioxide out of the atmosphere and locking it down into stores to help lower our atmospheric carbon dioxide levels. And that technology has been invented millions upon millions of years ago. It's called photosynthesis. It's what trees do. They suck carbon dioxide out of the atmosphere, combine it with water, and turn it into energy and biomass. And as long as that wood stays within the tree, it represents a stable store of carbon, or stays within the wood. So you can also build a wood building and also have a stable store for carbon.
And when it comes to actually quantifying the quote unquote negative emissions potential of a tree and by extension then a forest, how does that work?
So we know with a high degree of certainty that trees can absorb carbon dioxide from the atmosphere. We also know that how quickly they can do it varies a lot across the globe. Trees in the tropics, for example, grow much, much faster than trees up in the boreal. And it's very easy to actually measure how quickly a tree is sucking in carbon. You just go out and you take a tape, measuring tape, and measure the diameter at breast height and how tall it is, and can look up wood density from a table or measure it yourself, and you've got a sense of how much carbon it's captured. The trick is that takes a lot of time to have somebody going out sort of tree by tree. And so what we do is try to find all the best available estimates from people that have gone out and collected those, and then pull them together into these massive databases that you can then use to develop good predictions of how quickly regrowing forests can help to pull carbon dioxide out of the atmosphere.
Can you speak to how technologies such as satellite imagery and remote sensing have the potential to measure forest density on a fine scale and quantify the amount of carbon forests all over the world might be capable of storing?
We are just on the cusp of, I think, really getting that. Before remote sensing technologies were best set up to sort of figure out changes in forest cover. It's easier to see, whereas biomass is a lot harder because you have to get that sort of complex three-dimensional structure of a forest to really quantify biomass. And so that's actually where there's this really wonderful interplay between these sort of field-derived measurements that we typically use and remote sensing measurements, and sort of calibrating those two so they speak well to each other. And the remote sensing technology is improving every day and getting better and better at doing that. And as we get more and more field plots, our understanding of how rates will vary with the factors you mentioned, like what's the site condition? Is it on a hill? What part of the world are you in? We know a lot of that already from field data, but remote sensing will help make that process of refinement much faster.
One of the topics that you've written about is the comparison between old growth forests and second growth forests in terms of their effectiveness to capture carbon. Can you talk about what we mean when we say old growth forest versus second growth forest? What is that? And what have you found is the difference in effectiveness?
Trees follow a sort of S shape in development, where if you're looking at how much carbon they're sort of actively pulling out of the air, it can be a little slow at first. And then once the trees get established, you get this really rapid pickup. And then eventually the trees mature and they stop sucking carbon out of the atmosphere as rapidly. But those so younger trees, or that sort of middle age, those are the ones that are best able to really pull carbon dioxide out quickly. But on the other hand, the old forests are storing a large amount of carbon that they've accumulated through time. So when we're thinking about, would you want to prioritize protecting standing forest versus cutting it down and regrowing it, it's usually better, with lots of caveats that I could go into, to keep the forest standing. It's the whole old adage, like an ounce of prevention is worth a pound of cure. And it's much more cost effective usually to keep the carbon in the land than to try to regrow it after the fact. And then of course the caveats are, what are you going to do with the wood? So if you put it into long-lived wood stores like a building, it can make sense to do the harvest instead of using something like concrete or steel.
So those caveats that you mentioned, what are the considerations that need to be kept in mind when we're thinking about planting a new forest versus, maintaining what we have, maintaining the old growth?
We're trying to think about all the different ways that we can use nature to help tackle climate change. And before we even think about that, the first and overarching message is that we have to decarbonize our economy first, right? It's not about using nature instead of reducing our reliance on fossil fuels. It's about doing both. So I always like to say that. And then the next thing I want to emphasize is that there is no single best way to use nature to tackle climate change. It's really going to depend on what makes sense in a given context. What does the community want? What does a country need? What is a corporate actor interested in? And so that's what we try to do, is present more of a menu of approaches. That said, there are various factors you might want to keep in mind when thinking about which to pick. So as I was saying, these sort of old forests store massive amounts of carbon. And if they're lost and that wood doesn't go into a long-lived store, it's sort of effectively poof into the atmosphere and you've lost all of that. It's much harder to regrow it. So that would argue for using protection rather than trying to restore. Another factor you might want to think about is time lag. How quickly does the carbon go straight into the atmosphere versus how quickly is it pulled down? Also cost, and then these sort of broader feasibility things. What does the community want to see out of their landscape?
So Susan, I'd love to dig into the reforestation side of the conversation. You were lead author on this amazing paper that came out in December 2020 about the available opportunities to restore forest in the contiguous United States. And this work has been turned into an amazing tool called Reforestation Hub. And you can check that out at reforestationhub.org. It's really incredible. It's also like visually captivating and just cool to look at. Can you take us through the inspiration and the methodology behind this work?
Great. Yes. And thank you very much for your kind words. It was a great project done in partnership with a lot of people, including American Forest, who helped fund putting all of our science up into the Reforestation Hub. What motivated us to do that work was, so there's two things that influence the power of reforestation as a climate solution. One is how quickly can it pull carbon from the atmosphere? And then the other is, where the heck are you going to put all those trees? And so this project was intended to address that latter question. Where are you going to put all these trees? You know, when people estimate the potential for reforestation, there's sort of a few things that you have to make sure. Like one, you want to put trees where they naturally occurred. It doesn't make sense to put them in natural grasslands, for example. It's bad for biodiversity and the trees usually don't live. And then, you know, you're not going to put a ton of trees smack dab in the middle of a city. You don't want to put them where we need to grow food. So there's sort of these places that you exclude. But then you often have a lot of sort of other area left over. And the question is, what is that other area? And how much of that area is actually feasible for reforestation or not? And so, you know, we looked at other maps of reforestation opportunity that we ourselves, you know, had done as early versions, and would say like, oh, that's a power line right away. That's a post-burn landscape. Like, oh, that's a golf course. They're very, very different likelihoods of wanting to get trees back into those landscapes. And so our goal was to build in, it's basically a stacking a bunch of different spatial layers with different pieces of information to try to say like, okay, here are the locations that are in croplands, but the soil has imposes severe constraints on production. So it's more marginal cropland. Or here's a spot that you could put trees that's within a place that floods once every 5 years. And as flood events are unfortunately becoming more frequent with climate change, you know, putting trees back into that landscape can provide carbon capture as well as all of these important flood mitigation benefits. And so that was the goal, to build up all of these layers and then show sort of at the county level, okay, here's your menu of options. Here are the ones with the biggest opportunity. Now you can take that information and decide like that one works for me, that one doesn't, and start honing your focus on those that make most sense.
What makes a good spot for reforestation, and what are the different parameters by which you sort of categorize different locations or areas for their reforestation potential in your work?
We first published a study where we broke down reforestation opportunity into a menu of 10 different options and focused on sort of 3 general categories. The first were things that were already in a natural land use, because we assumed that those would be easier to get trees back into land because you don't have to shift how it's used. The next were places that humans were using, but they were potentially lower value, so more like marginal croplands or places that are flooding too frequently for farmers to make a consistent livelihood from those landscapes. And then the third general category was places that offered high co-benefits. So those are also the floodplains because of all the downstream benefits you get, as well as areas within 30 meters of a stream, for example, because those trees can help keep pollutants from adjacent fields, for example, getting into the water. And then finally, sort of more open urban areas. We didn't consider dense urban cores because that's just a different beast. You're sort of going tree by tree, you know, in a sidewalk. And yeah, so the study found where those opportunities fall, how much carbon you could get from them, how they vary by region. But we realized that there was all of this really rich information, and you know, it was available to those who really wanted to like get the spatial layers and put it into GIS, but that is not they were not readily accessible to people who might want to use it to make decisions about whether and how and where to use reforestation. And so we had this great opportunity to partner with American Forest to build all of that information into a easy to use platform.
Yes, that's what I love most about it. It's so easy to use. And once you're in the hub, you can toggle between viewing data in acres or metric tons of CO2 per year. Can you explain the logic behind that and the meaning of these different variables that you can play with in the hub?
So we typically measure climate mitigation potential in terms of tons of carbon dioxide per unit area, like acres per year. And that number, tons of carbon per carbon dioxide per acre per year, will vary across the landscape depending on forest type. So we use numbers that were sort of specific to forests that were native to that area. So what that means, you get lower numbers out west because the trees are slower growing, and also they tend to be more widely spaced because of their fire-prone landscapes. You don't want to pack it full of trees, compared to other places where a greater density of trees is more appropriate given ecological conditions.
Got it. So you basically take data that's been previously gathered, which analyzes forest cover in all these areas on a pretty granular level, and then you characterize the sequestration potential. Is that right?
That's right. So our actual estimates of carbon sequestration potential come from the U.S. Forest Service, but they use the forest inventory and analysis plots, which are scattered across the U.S. To build these sort of general growth curves for a forest type. And then they tell you where those forest types belong. So we say, okay, for everywhere where we would expect this forest type, we'll apply this carbon sequestration rate based off of U.S. Forest Service data.
Were there any results from this study or information that surprised you that you weren't expecting to find?
I think what I really like is if you go to the Reforestation Hub, you can select we had our menu of options. So one of them is just total opportunity, but then there's sort of opportunity on federal lands, opportunity in pasture lands, opportunity in floodplains. Like you can click those options on and off. And what I really like to do is sort of look at the level of the US and look at total opportunity, where you see a very strong opportunity in the East. And that's primarily because trees grow quite quickly in the eastern part of the US. But then if you click the federal lands button, the West will pop up because most of our lands are in the West, our federal lands are in the West. And so it's really about like, okay, what is it that I want to prioritize? Like, do I want to prioritize trying to do outreach to a lot of private individual landowners in the East where trees can go quickly, or do I want to work on changing federal policy to increase reforestation on federal lands? And just that there's no one size fits all choice, and how the hub makes that obvious.
And the fact that you've hit this sort of sweet spot between reaching policymakers and individual people, I think is what makes this tool so powerful. Can you tell me, how are you seeing the hub being used by policymakers or by the private sector, by individuals?
We actually wound up sharing early versions of this with partners because we knew people were actively trying to figure out what did they want to do to address the climate crisis, and to determine, does reforestation make sense to me? How much reforestation would we want to do and where? And so people were very excited about it from the beginning, and having it sort of published enough was like a final note on a long process. And what we've seen is that sort of state level decision makers are using it in their climate action planning to figure out, what makes sense to us, where might we want to prioritize action. We're seeing fellow NGOs using it to help develop reforestation strategies as well. And we've had some conversations at the federal level where people are using it to sort of right size a sense of how much potential there actually is to use reforestation as a climate strategy.
So you made the tool. What was your vision for how it would be used?
My goal is really just to get the best information out there to people who are trying to decide whether and how to use reforestation. And, it's really for anyone who would want to play and think about their opportunity from the county level up. And it's always improving. So we've actually updated it recently to build in some additional grassland safeguards. And as we get better carbon estimates, we can update the hub too. So it's just a place that tries to get all the best available information into a single resource. And for example, you'll also see we link to all of these great resources that other organizations have developed about how to plant a tree, what species make sense in my area, because there's a lot of great information out there. It's just often distributed. And so I do think there's value to just pulling it all together into a hub so that it's easy for people to find.
So is that the next step for this work, building the robustness of this hub, or are there other plans for the data set? What questions are really exciting you at this point?
So what I am focusing on right now is that there are different ways to get trees back into the landscape. You could go out and replant an entire field. You could plant a few trees that sort of act as the seeds by which the forest can grow around it. You could just, put up a fence, take off the cows, let the forest regrow on its own. People could set up an agroforestry system or silvopastoral system, or a timber plantation. And depending on your approach, you're going to get very different carbon returns, economic returns, biodiversity returns. And so that's what I'm trying to do right now, is figure out what are the benefits and the trade-offs between these different reforestation approaches. And then how does that vary across the globe? So my work is actually global in nature, that we do deep dives in individual countries like the United States.
What do you think about, selling carbon credits based on forest carbon sequestration? Do you have any thoughts on sort of this marketplace at the moment?
So my work is a bit agnostic to who uses it. So what I'm really trying to do is get the information out there so people can, one, figure out where there might be opportunity, and two, figure out how much carbon they could get if they restore forest to those landscapes. Carbon markets, of course, require an additional level of rigor to make sure that the projects are additional. So that means that the carbon finance is necessary to have had those trees grow back, right? Because what we really need is action beyond the baseline. Like, we can't just keep trekking along the path that we're on. We need to do additional action. And then there's sort of other criteria that you need to check off to make it a viable carbon crediting project. I don't think about that as much at my work. It's really just, let me give you the science that you can feed into making those decisions. But then it's up to people to use it wisely.
So, Susan, we started the conversation talking about, your anchors to the future, your children, and why you do this work. But how do you talk to them about climate change, about what's being done or not done? It seems like an important conversation, an important one to have, but it's sort of frightening. How do you approach that?
Yeah, so my kids are still very young. And I guess the level that I've kept it at is that there's a lot of pollutants in the air, and we need to work to get them out of the air. And that I'm lucky enough to have a job that figures out how we can best use trees as one of those solutions for pulling carbon dioxide out of the air. I think she has plenty of time to deal with all the horrors of climate change. But we have 10 years to constrain the climate crisis. And, I fight every day. And it sounds like, given the theme of your podcast, you are also part of the fight to build a better future for everybody.
Susan, thank you so much for taking the time to talk with us today. We really appreciate it.
Well, thank you for covering our work. It's great to get this information out there.
Susan Cook-Patton, Senior Forest Restoration Scientist on the Natural Climate Solutions Science Team at the Nature Conservancy. For more information on her work and that amazing Reforestation Hub, you can check out our website, climatenow.com. You can watch our videos, listen to our other interviews, and sign up for our newsletter there as well. And if you want to get in touch, email us at contact@climatenow or tweet at us at WeAreClimateNow. We hope you'll join us for our next conversation.